What's up, everyone? This is LeetCode 9, Palindrome number. We've done this problem in Python, but now we're going to do it in C++. So we're given an integer x. We have to return true if it's a palindrome, and false otherwise. So, right, a palindrome, it reads the same forward and backwards, right? So, for example, this number x, right? 121 reads the same forward and backwards, right? 121 reads the same forward and backwards. So, if you go forward, it's 121, go backwards, right? 121, right? Reads the same forward and backwards. Or I guess left to right, if that's easier for you to understand. But obviously, look at this, right? Example 2, we have a negative, right? This actually has to get counted in terms of whether it's a palindrome or not. So as you can see from left to right, we have a negative symbol, we have 1, 2, 1, but when we read right to left, we have 1, 2, 1, but we have the negative symbol on the right here, but over here we have it on the left, right? So this doesn't read the same forward and backwards, so we have to return false. Here, left to right is 1, 0. Right to left is 0, 1. So it doesn't read the same forward and backwards. This is not a palindrome. So you can use like a two-pointer approach. That is a possible way to solve this problem. In fact, it's kind of the more simpler approach. But that's really not the challenging part about this problem. The challenging part about this problem is the follow-up, right? Could you solve it without converting the integer to a string, right? Because you can use a two pointers if you just convert this integer to a string and then, set a pointer at the start of the string, a pointer at the end of the string, and compare the values, see if they're palindromes or if the number is a palindrome or not. Well, it would be a string after you convert, but you get the point. But we're not going to do that, right? I think that solution approach is very easy as is. So we're going to focus on actually handling the checking for this being a palindrome or not without converting to a string, okay? Like, we're basically only doing the follow-up, which is, I think, the actual hard part about this problem. The two-pointer approach is not hard, so I'm not going to waste time on that. So I'm going to show you how we're going to do this, okay? So we have, right, we have a number x, okay? This is just an example number, 15451, okay? And we're going to check if it's a palindrome. And the way we're going to do this is we're going to basically take whatever x is and put it in another variable called dummy x, okay? So dummy x is the same as x initially, right? And we're also going to create a variable called reverse number, and we're going to set that equal to 0. Okay? And we're basically going to use dummy x. Oops, I had some lag there. We're going to use dummy x to build out reverse num and actually get the reverse number, which is basically x reversed. And we're going to basically store that right here, okay? So the way we're going to do this is we're going to continually loop, right? And honestly, even before we do that, we can check negative numbers as like a base case, right? Because remember, those are never going to be palindromes, right? Because they're not going to read the same forward and backwards because of this symbol. So basically, if x is ever, just to start with, right, at the start of the program, we're going to have a base case where, right, if x is like less than 0, right, just return false. Because it's always going to be false if it's negative, right? Because this symbol would always make it not a palindrome, okay? So that would be just a base case we would handle. And now let's actually handle checking whether the number is a palindrome, right? Because if we're actually doing this, then that means x is greater than 0, or greater than or equal to 0. So let's check, okay? So we have a number x, right? That's our input, right? We also create another variable called dummy x with the same number, and we create a variable called reverse num and set that equal to 0. So we're gonna have an algorithm to reverse this. We're gonna have an algorithm to reverse x, and it's gonna go like this, okay? We're going to take, and let me just draw it out actually, the algorithm, just so you don't remember, don't forget. We're basically gonna take reversed. Actually, I don't want to spell it all out, because I don't know if I'll run out of space. And let me use a different color that I haven't used. Oh, we'll just use this. Rn stands for reverse number, okay? So we're taking whatever's in here at a given point, multiplying that by 10, and then we're adding basically whatever dummy, let's just call it dx, dummy x, right? And we're going to mod that by 10. Okay? And we're going to and that's basically, we're going to store that up here. Okay? So we're going to take whatever's in reverse num, multiply that by 10, and then add the mod of dummy x. Okay? Let's go through this, right, step by step, just so you kind of understand what this formula is doing. If this is confusing, you don't have to pay attention to it. I'm just drawing it out just so you know what the steps are, basically, in this algorithm. Okay? So let's take reverse num, which is 0, multiply that by 10, right? So reverse num 0, multiply that by 10, obviously that would be 0, and we add whatever dummy x mod 10 is, which would be the last digit, right? 1. So we would basically do 0 plus 1, and that would be, and basically after this would be like a loop, right, in our code. After we do the loop, we basically update reverse num with whatever this result is, okay? So 0 times 10 plus mod of dummy x would be 1. So 0 plus 1 is 1, okay? So let's delete this, and we're going to put 1 right here, which makes sense, right? So far, so good, because we should be building this. Reverse num should be this number, but in reverse order, right? Okay. Now, let me explain really quick before we move on to the next iteration. The reason we're doing times 10 is because obviously when we go this way, right? When we're building out this number, we should have basically 10 times more, meaning obviously we start in the ones. We're doing this backwards, right? So we'd start, so this is the ones place, but technically we're building this backwards. So this would be the ones place. So we start out in the ones place, right, in the tens place, and the hundreds. So that's why we have to times it by 10, right? Because here we have 1, right here we had a 50. Next step we would have 51. Next step we would have 451, right? Then thousands, 10,000, right? So that's why we're multiplying it by 10. We're basically just extending our number. If that makes sense. Don't get confused, but hopefully you can see what we're doing. So yeah, we have 1, right? Now let's handle the next loop. So we have reverse number times 10, so that would be 1 times 10. So we would have 10, and we have to add, I forgot an important step, I'm sorry. Before every time we finish a loop, every time we do this and update num, right? We need to basically chop off this number, the last digit that we just handled, because we don't want to account for it twice, right? That would make no sense. So basically, this is the point of having dummy x, right? Instead of using x, is because dummy x is shrinking as we use these digits up, right? And at some point, we're going to have a remainder of 0 in dummy x, and that's basically going to be our condition to break the loop and just check if this is equal to this, okay? And obviously, we need x, right? Because we need to compare that to the reverse of x. So this can never change because we need it to do the comparison, which is why we make a variable called dummy x that actually does change. This can never change, right? It has to stay the original value, which is why why we create dummy x in the first place, because x can never change. We have to use it at the end to compare x to the reverse of x. So this can never change. That's the point of creating dummy x. I know you were probably confused at the start of the video, and I'm kind of answering a bunch of questions you may internally have. So I'm sorry. I'm just explaining as I go, and hopefully, I clear up any confusion. This problem isn't too hard. I just think it's hard to explain for someone who's seeing it for the first time. Okay. So we have x, we have dummy x, we have reverse num. So we did one step, okay? Obviously, want to cut off this number. And instead of cutting it off, let me just, or instead of Xing it out, let me just delete it. Okay, next step. Reverse num times 10 is 10. And we want to add the dummy x mod 10, which would be 5, right? So we have 5. 10 plus 5 is 15. I'm deleting this just so I don't have a lot of work on the screen. Okay, we're building this number out backwards, so far so good. We have 1, 5. Let's delete this number that we just used on dummy x, right? Or the digit, not the number. Next step, okay? Reverse num, 15 times 10, that's 150, plus mod 10 of dummy x, which would be last digit, so it'd be 4. 150 plus 4 is 154, right? We're building this out backwards, so far so good. Let me delete the last digit. Okay. Oops, let me delete my work from the previous step. Next step. Reverse num is 154, times that by 10, we get 1540. And we're adding to that the last digit of dummy x, which would be 5, right? And that would be 1545. So update reverse num 1545. Delete this last number. And by the way, like the way we're the way we're actually, like, in the code, the way we're so when we have a number like this, the way we're actually shrinking the number is we're taking dummy x and just dividing it by 10. That's how we're chopping off the last digit. Okay, and at some point, right, we're gonna have like 1 divided by 10, and that would give us 0, right? Because we're it has to be an integer, right? So anyways, we're on the last step. We have a 1 left, right? Okay. So we're going to take reverse num, which is this, and multiply that by 10. These numbers are starting to get big. 15,450 plus the dummy x mod 10, which is obviously just 1. And so we add that to reverse num, and this is our final num, right? Now, our final step, we would basically divide this by 10, and dummy x, oops, I deleted this. Our dummy x would be 0 at that point, and so we would exit this loop, and we would stop basically using this, you know, formula or loop in the code. And so basically it would be at the end of our program, and so we would check, is x equal to the reversed number, and we would just return that. And as you can see, we have 15451, 15451, and so we would return true. Obviously, using your eyes, you can see this is a palindrome, but, you know, we're checking this with a bunch of test cases, which is why we have to have the algorithm, obviously. But yeah, that's how the algorithm would work, okay? Now, this is a little bit simpler in Python because you don't have to worry about integer overflow or any of that stuff, whereas in C++ you do, right? So let's handle our base case first. So we're going to say if x is less than 0. Hold on, I need to move my microphone a little bit. There you go. Okay, we're going to say if x is less than 0, right? We're just going to return false because that negative symbol would just make it not a palindrome in every case. Okay, now we're going to use long instead of int, right? Because with an integer, we could have an overflow, right? Integer overflow, which is why it's very important to pick your types, your data types, well in C++, right? You don't want to use an integer. You don't want any overflow. So we're gonna say dummy x is equal to x, right? This is our dummy x, and we're gonna have a reversed num, right? And we're gonna set that to 0. Now if for some reason you had like a crazy constraint and long was not working, or like you could have overflow with long, you could just use long as well, right? But there's no point, right? Let's not use any more space than we need memory-wise. Not that it matters that much in this problem, but we don't want to allocate any more memory than we need to. So we're going to say while dummy x, and you can say while dummy x, or basically just do while dummy x is not equal to 0. Or you could say while it's greater to 0, whatever. I mean, same thing. Dummy x at some point to exit this loop is going to be 0. right? Because we're dividing by 10 every iteration of the loop for dummy x. Okay, I'll just say while dummy x. You can say while dummy x is not equal to 0 or whatever you want, doesn't matter. Okay, this is where we have to start doing the actual work, okay? Now, if you remember, we're going to basically take reversed. We're going to take reverse num, multiply that by 10, and we're going to add dummy x mod 10, right? But we're not done yet, because where do we have to store that? We have to store that in reverse num, right? We're updating that every iteration, okay? And not just updating that every iteration, but every iteration we have to chop off the last digit for dummy x, because otherwise we're in an infinite loop. And yeah, let me go really quick. You can pause the video here and then right here to check what we're doing, right? Just like we did, except now we're doing it in code, right? So yeah, this is how we're doing it. And then down here, right, we have to return is x equal to, or if x is the same as reverse num or not, right? And I think that's it. I don't think I made any logic errors. And there you go. So this problem is not that hard to understand. You just kind of have to understand, like, what are we actually doing? Because at this step, technically we're doing two things, right? Because when we're building out this number in reverse, we're at 1. When we add this to 1, we need to go to the 10th place, right? So that's why we multiply it by 10. And on top of that, we need to get the last digit of dummy x, which in this case, dummy x would look like this. So we have to get this 2, right? So we would have, you know, this. So we'd have 1. 1 times 10 is 10. 10 plus, and then this digit would be 2. Last digit of dummy x would be 2. So 10 plus 2 is 12. And that'd be, so far, reverse num would be 12. And makes sense because when we're going backwards, we have 1, 2, right? Etc. Yeah. I mean, you can run through some own, like, you can come up with some examples on your own, like test cases on your own, and go through this by hand, like if it makes it more easier to understand what exactly is going on. But if this isn't too difficult, I would say, like, I did this problem maybe 2 or 3 times on my own, like came back to it, and then it made sense, right? So like if you're doing it for the first time, you might not, if you come back in a few weeks, you might not remember it, this problem, which is okay, because that's how you learn, right? You do repetition. But yeah, I hope this explanation was as clear as it can be, and I'll see you in the next one.